1-3. We're going to be talking about measuring segments today. And the first thing we do, it's called the ruler postulate, and it's just a way for you to tell the length of a segment given points on a number line. Okay, so if I'm given points on a number line, they'll represent where they are with capital letters. These are representing the numbers. Okay, so the way we do it, the way we tell the length of AB, that's what this is saying. What is the length of AB? Okay, is we take the value of the lowercase a, the value of the lowercase b, we subtract them, and then what do these bars mean? Absolute value. What happens with absolute value? It becomes positive. It's the distance from zero. Distance can't be negative, so it always becomes positive, okay? So this is very simple, very straightforward. All you do, if I want to know what is the length of ST, okay? S is at -4, T is at 8. So the length of it, ST, is going to be the absolute value of the difference of those numbers. Difference means what? Subtraction. So you're going to say -4 minus 8. You could flop that, right? You could say 8 minus -4. You'll get the same answer because when you take the absolute value, you get the absolute value of -12, which is a length of 12. Okay, so it is 12 units between S and T. Okay, so tell your neighbor the length of SV. How long is SV? Use that ruler postulate and find that length. What'd you get? 18. Ooh, 18. So you're taking the absolute value of the difference, okay? And I'm just going to show you that it works either way. So I'm going to switch it up. I'm going to do V and then S, but you could have done it S and then V. V is 14. You're subtracting the other number. So here's where you have to be careful. You're not subtracting 4. You're subtracting what? -4, okay? So minus a -4 is plus a positive. So it's the absolute value of 18. And the absolute value of 18 is 18. So the length of SV is 18 units, okay? Okay, this is what you're going to spend most of your time on today. Yes, sir. Oh, was that a hand up too? Go ahead.
So if one of those numbers is negative, can't you just remove the negative sign and just add the 2?
If only one is negative, yes, that would work. But you're just doing the math in your head, essentially, right?
Yeah.
The rule is you're subtracting, but because a number is negative, you can add the negative, which is, yes, add it and then take the absolute value. So, yes. Okay, segment addition postulate. You're going to see this a lot in this course, okay? This is a very popular thing to do in geometry. So if you struggle on this concept today, please ask me, okay? Here's what it says. Segment addition postulate is basically, have you ever heard the two parts equal the whole? You probably did stuff with that back in like early math classes in elementary school. The parts plus the part equals the whole, right? That's what segment addition postulate is with segments. So what it's saying is if I have the length of AB, okay, and I add to it the length of BC, it will equal the whole thing, which is the length of AC. Okay, so AB plus BC equals AC. I did it this morning with my other class, like with my arms. If I go, here is an entire segment from fist to fist, right? So here's my segment. This being one of my segments, elbow to fist here is one segment. Elbow to this fist over here is another segment. If I add those two segments together, I get fist to fist, right? The whole thing, okay? So segment addition postulate. Here's what your questions are going to look like with this. If EG equals 59, Okay, so they're saying E to G. Here's segment EG. It is 59 units long. I want to know the length of EF, and I want to know the length of FG. Remember, the two parts equal the whole. So what are the two parts right now? This is one part, 8x minus 14, yep. Yeah, this is the other part, FG, okay? All we do with that is we add them together because we know what the whole thing equals. So it's going to be 8x minus 14 plus 4x plus 1, and we set that equal to the whole thing. And then from there, it's algebra, okay? At this point, do the algebra. So the two parts added together equal the whole thing. Now, I will tell you right now where people get stuck on these problems is they forget to read the problem. They forget that there is information up here that's super helpful, right? If you don't remember that EG is 59, you can't solve this. So make sure you read the question all the way through and then try to set it up. So if you simplify this, 8x plus 4x is 12x. Negative 14 plus 1 is a negative 13 equals 59. Add 13 to both sides, right? Oops. Not a negative 13. That's just my pen being funky. So that goes away. Add 13 here. You get 72 equals 12x. Divide by 12. How's your mental math? 6. Good job. Are we done? The question didn't ask for x, right? It says what's the length of EF and the length of FG. So now you're going to take that 6. I should have written smaller, sorry. You're going to plug that 6 in here, and you're going to plug that 6 in here. So EF is going to be 8 times 6 minus 14. How's your mental math? 34. Okay, so EF is 34. Then you're going to plug it in for FG. Again, I should have written smaller, but we'll do it here. FG is 4 times 6 plus 1. So FG is 25. Okay, now, how can you check that? Add them together. 34 plus 25 better equal 59, right? And it does, so we know we did it right. Questions on that? All right, so that's segment addition. Take the two parts, add them together, they should equal the whole thing. Anyone know the symbol that we use for the word congruent? Do you know what the word congruent means, first of all? It means equal, okay? Congruent segments are equal segments, segments that are equal in length. So there is an equal sign in congruence, but then there's the little tilde over top. It looks like the little ñ, right, in Spanish. So congruent segments, we're going to use that symbol to represent it, but basically what it says is if the length of AB is equal to CD, then segment AB is congruent to segment CD, okay? Equal lengths is congruent segments. All right, so we're going to use that ruler postulate that we learned at the beginning, and we're going to determine if these two segments are congruent. Can anyone tell me the length of AC, or how do we find it? Yeah. Okay, but how do we find it?
Can you just count on the graph?
You could just count it on the number line. Do you remember what the ruler postulate says to do? The absolute value of the difference, right? So if you look at A is -2. C is where? 5. So you get the absolute value. -2 minus 5 is -7. So that is a length of 7 for AC. Okay. If I ever get going too fast, by the way, just tell me to slow down. I'm not trying to go too fast for you. My brain just starts to move a little too fast every now and then. So tell me to slow down if I'm going too fast. BD, again, you're taking the absolute value of the difference. Where's B? 3. Where's D? 10. So you get the absolute value of -7, which again is 7. So we would say, are they congruent? Yes. And here's how you write it, okay? Segment AC is congruent to, okay, so whenever you see that congruent symbol, is congruent to, and then the other segment, segment BD. Questions on that? Okay, here's the other thing you're going to do a lot of in this class. So we did segment addition postulate, which said the two pieces added together equal the whole thing, right? Now we're going to talk about a midpoint of a segment. Any guesses what a midpoint of a segment is? It's the middle, right? The midpoint is the middle point. Isn't that convenient? So the midpoint of a segment is just a point that divides a segment into two congruent, or if you don't want to write the word, you could write the symbol. I will use that symbol a lot for the word congruent, just FYI, okay? So it's going to divide a segment into two congruent segments, which gives us what's called a segment bisector. Now, when something is a bisector, it's cutting it into two equal parts. So midpoints and bisectors are very similar, okay? A segment bisector can be one of several things. It can be a point, it can be a line, it can be a ray, or it can be a segment that's cutting a segment into two equal parts. So this point is a segment bisector, or this line, line L, is a segment bisector, but we would say B is the midpoint of that segment, okay? Notice these little hash marks they put here. When you have the same number of hash marks, that means they are congruent. So like, if I were to put something like this, and then like this, okay? If I put 2 hash marks here, but then the other 2 are also equal, but they're not equal to the first 2, I gotta put a different number of hash marks. So it could be 1, it could be 3, okay? But that's how we show that things are equal, okay? So just look for those little hash marks as we go. You'll do a ton of that this year as well. Okay, so example 4 here. Example 4 and example 2, people get mixed up a lot, okay? So if example 2 felt really easy to you, like, yeah, this is fine, I got it. Don't just assume that you've got it moving forward. Make sure you read the question, because it's all about how it's worded as to how you're going to set it up, okay? This one is saying Q is the midpoint. That means this point right here is in the middle of that segment, which means these two pieces are congruent. Okay, now what you notice different about this one is they did not tell us what PR equals. Do you see a value for PR anywhere? Okay, but they did tell us it's a midpoint, which means what do we do with this information? Nico.
You put 6x minus 7 equals 5x plus 1.
Right, so on this one, when you have a midpoint, you set them equal because they are equal in value. When you don't have a midpoint, don't set them equal. When you don't have a midpoint, you add them together and you set it equal to the whole thing, okay? So this is going to be 6x minus 7 equals 5x plus 1. And then we're just going to solve that. So algebra from here, take away the 5x. And you're left with an x on the left. Add the 7. And you're left with an 8 on the right. So our x value is 8, but they didn't ask for x. They asked for 3 different segments, right? They asked for PQ, QR, and PR. Can anyone tell me what PQ should be? So you're going to plug in the x, right? 6 times 8 minus 7. So 48 minus 7 would be 41. Right? Okay. What should QR be before you even calculate it? 41. Because this one was 41, QR should be 41 also. They're equal, right? It's a midpoint. But I always recommend that you still plug it in just to make sure that you didn't do something wrong. So 5 times 8 plus 1 is 40 plus 1, or 41. So what is PR? 82. Take those two pieces. 41 plus 41 is 82. Okay, do you see the difference between example 2 and example 4? Example 2 says this is a midpoint, or sometimes they'll just mark it. They'll mark them congruent. Then you know it's a midpoint. Example 2 said, here's the pieces. The whole thing equals this. Set it equal to the whole thing. Okay? Okay. Technically, I'm done with the notes, but I'm going to give you 2 more examples just for the setup of them. So you don't have to write this down. You may, if you want to write it down, that's fine. But I want to know, if I give you this, what are you going to do with that problem to solve for x?
Add them together and then do multi-separate.
Yes, so you're going to add the 2 parts together, right? AB plus BC should equal the total, right? They told us what the total was. Okay, so you set it up like that, you solve it. If instead I gave you that, what would you do? Set them equal, because these little marks mean that those are congruent segments, right? The little hash marks mean they're equal. So you would just set these 2 things equal to each other. Does that make sense? All right. What are you going to bring tomorrow? Protractor. Good.